Hello everyone. So today we have a Codeforces Div-4 round, and yeah, I am participating after a long time. Like I did participated in a few rounds a week or so ago, but those did not go all that well. So I decided not to upload their screencast, but hopefully this will be up. So Taimur likes his name, the spelling of his name allows any permutation of letters of the name. For example, the following strings are valid spellings of his name. Taimur. Okay. Must have uppercase T and lowercase other letters. Today he wrote string S of length n consisting only of uppercase or lowercase Latin letters. Ask you to check if S is correct spelling. Okay, so after these four names, what this is also invalid. Okay, so it can only be a permutation of this thing, right? So mm, okay, so if m dot size is equals to mp dot size, then only come inside this loop. And okay, in k, if tab of ch is equals to mp of ch, else let's just say that f equals false, I think. Okay, so let me do it like this for now. Good. M dot size equals mp dot size. Oh, mm, okay, so we have 7 problems today. Colorblindness has a grid, 2 rows and columns. He colors each cell red, green, or blue. Is colorblind and can't distinguish green from blue. Determine if Vasya will consider the first 2 rows of the grid to be colored the same. Okay. So yeah, for this one should we know? If one is red and the other one is green or blue, then we have a problem, otherwise we are good to go. And okay, yeah, so this one if or s of I is not R but s1 of I is R, then f should be false. Yes, no, yes. Word game. Three guys play a game. First, each person writes down n distinct words of length 3. Then they total up the number of points as follows. If a word was written by one person, that person gets 3 points. Two people, then both of them get 1 point. Written by all, nobody gets any point. In the end, how many points does each player get? What? Okay. So I can have all the words in like separate vectors, and then if I do like lower bound, will that work or will that give clearly? But length can be just 3. I think that should not be an issue. Right? Or the v of I should be a vector of string of length, and then that will work. That also like sort v of I. I think it is a inbuilt function. So if sum is 1, then do score plus equals 3. Else if sum is 2, then do score plus equals 1. Else do nothing. We can also have the ideal array. Hmm. 9, 8, 7. So each number can be added at most 2 times. Okay. Don't see a solution for this one right away. I think let's try our problem E as well. Counting rectangles. And rectangle size rectangle has height hi and width wi. You are asked Q queries of the form hs, ws, hb, wb. For each query, output the total area of rectangles you own that can fit a rectangle of height hs and width ws, while also fitting in a rectangle of height hb and width wb. L shapes. Okay. Determine if it contains L shapes only, where L shapes cannot touch an edge or corner. More formally, each shaded cell in the grid is part of exactly one L shape, and no two L shapes are adjacent by edge or corner. Okay, so like this. This one. This one is purely implementation based. Even odd XOR. Given an integer n, find any array of n distinct non-negative integers less than 2 to the power 31 such that a bitwise sort of the elements on odd indices equals the bitwise sort of the elements on even indices. Okay. There can be at most 10 to the power 5 numbers. And all of them has to be distinct. So I was thinking of an array where ai equals to I only, but the duplication thing can be an issue there. And distinct non-negative integers, so the XOR can be 0 as well. Okay, let's do D only. How many summations? D has 464 summations. accepted solutions. So I can do one thing, which is I equals n minus 1, I think, and I greater than n by 2, like in this case 10 by 2 is 5, so 9, 8, 7, 6, or that will be 5 only, and here also it will be 5 only. So yeah, n by 2, 9, 6 less than or equals, but like in the case of 9 it will be 8, 7, 6, no, it won't be 6, it will be 5 only. 8, 7, so will it be 8? Yeah, it will be 8. This should be 7, right? Yeah, but this is 5. Oh, this will be 6 and this will be 5. So yeah, 9 by 2 is 4. I should not go to 4 if I am talking about this person. Oh, so it can have only 4. Talking about this one, it will be having 5. This guy will have 6, 7 and 8. Okay, so not this but this. And then for int, so if n and 1, then do mn by 2 also plus. That's just a VB. Right. So this whole thing should not be done here, rather here and here. Here just do m of n minus I minus 1 minus minus m I minus minus, and also I have a variable called sum. have sorted this array. Now I is less than n minus plus j equals so from 1 to n, okay. J equals vv dot size, then break out and or like y answer dot size is less than n, keep on pushing some only and time in the other case do j plus plus, but first do sum plus equals vi or vvj minus v of n. And also do some consumptions. I think this is good. Okay. So it's good that they have mentioned to use long only. So let's use long. Come on. Come on. Or wait. Okay. Running. Accept. Cool. Now this one. Should I do that one or this one? Okay, so let's see how many submissions. E has more submissions, so let's do E. Ith rectangle has height hi and width wi. You are asked Q queries of the form. Okay, so let's see examples only. 2, 1, 2, 3. Oh, so there are two rectangles given. 2 3 and 3 2. Okay, then 1 1 and 3 4 is the query. Can fit a rectangle of 5 edges and diagonals. And fit into a 3 cross 4 rectangle. But what we need to find the sum of areas of all rectangles that can fit a 1 cross 1 rectangle inside of it and fit into a 3 cross 4 rectangle. What? Only the 2 cross 3 rectangle works because 1 is less than 2 and 1 is less than 3. Oh, so they cannot touch the boundaries. Yeah. And like this 1 cross 1 can be fitted inside 2 cross 3. Okay, so they want the answer for this thing only. Let's not think too much about the problem. So all such rectangles where the limits are these. And in log n time. Heights and widths can be of at most 1000 and the time limit is 6 seconds, so that's one thing. Time limit is 6 seconds. T into H into W, something like this. Because n like if the constraint was only on H, then I would have found the answer easily. Or if only W was constrained, then also I would have found the answer. But if both of them are constrained, ah, so I think I see, but still the same thing, like it will take a lot of time. Is it like a 2D segment tree? So I was thinking of a matrix of size H into W, basically 1000 into 1000 matrix, and for now let's just say that it is of size 5 plus 5. So 0 0 0 0 0, and so if this is 1, then this just denotes that there is a rectangle given whose height and width is 2 comma 2 cross 2. It denotes a 2 cross 3 rectangle, and let's say it denotes a 4 cross 3, denotes a 5 cross 2 rectangle. Then I want, let's say the query is given to be like the constraint is to find the area of this much thing. So the constraint on height can be from 2 to 5, and constraint on width can be from 2 to 3. And for this, I think we need a 2D segment tree, and I don't know how to write a code for it. I'm not sure if I have. Oh wait, I have. Like I still don't know how to use this code. And the dimensions are perfect. Let's comment it out for now. And let's write everything from scratch. And really don't have any idea how does these functions work. Okay, so one thing that I can see is that build y has been called inside build x, so I will have to call build x only, and build x doesn't require any argument dot idx idy tly tryy ly ry. What are these two things? Okay, so again quadx we need to call this thing and pass only 4 dimensions. Okay, this is cool. And for update x, update x is again calling update y, so I should call only update x, y and value. Wow, cool, very nicely done. So okay, so I am assuming that yeah, all of them will be 0 initially. That's good to know as well. Let's say these are n1 and now yeah, here only call update x and so can there be duplicate pairs? Number of rectangles you want and the number of queries. Oh, but we need the area. Okay, so instead of 0 1 I can store the area only. And what does this line mean? Okay, so let's not think about that. Let's focus on implementing. So vi0 also vi1 and put vi0 into vi1 there. For querying, let's land r, or let's both the things. So hl wl h don't know on what basis I have named them those. Okay, and then cout quadx just the area, and wl plus 1 minus 1 WR minus 1. Right? It didn't work. That could be an issue. So is this thing working fine? No. Yep, but it worked only for once. X, Y and value, what's the issue? This is my X, this is my Y. I'm just doing this. Oh. Should I go build X? That doesn't do anything. Update X. I am passing the X coordinate, Y coordinate and the value. N minus 1. Yep. That would be 1000 only, right? So inside update X. Okay, so let's say no. Let's see how many times it has been done. Oh, negative. Okay, it came inside this line. Value IDX, LX, RX. And then M minus 1. This is LX and this is RX. So N minus 1 is not minus 1, right? LX and RX. RX is minus 1. But N is so N is not defined here. Oh, so that is capital M. Okay. Now 641. This is 4. Oh, Alex, RX, LYR. So this should have been HR minus 1 and then WL plus 1. Yeah, 641, 90, 54, 4, and there is some issue. So this thing. Let's have another one, I think. But this should be long or into. Let's define int as ll, and here use 22, right? So let's call it mat. Initially everybody is 0. Now here do mat vi 0 vi 1 plus equals vi 0 into vi 1, and then mat and here set it as equals to 0. Cool. Fingers crossed. I think this should work. Yep, solved a 2D segment tree problem for the first time in my life. How many submissions must I have? Probably there exists some easier solution as well. Let's not think about that. How are we doing among our friends? Okay. So probably G is easier one. Let's go for G. How many submissions? Okay, so G has more submissions. Let's do G. If I kind of reserve a number for the last number of output array, then will that be helpful, or will that force me to reserve numbers at other positions as well? So if in the question, like if we just erase this distinct word, then the question is very easy. We can have anything from 1 to n minus 1, and the last number we can set accordingly. But if we try to extend that, think we can extend that. So the only problem will come in the case where the XOR of some numbers is 0. And in my solution I am saying that, let's say 1, 2, 3, 4 and 5. And let's say this number doesn't exist currently. Then the XOR of 1 and 3. So in this way, will I always have XOR greater than 0 for all the odd numbers, and for the even numbers for the even numbers the XOR can be 0, like in this case 2, 4, 6. And that will not change if I start from 0. Yeah, that will not change. So probably I should reserve the last even number as well. And in this way, last two numbers will be different, and the first n minus 2 numbers will be equals to I only, like the index. Yeah, so in the case of 8, let's have 1 to 6, and then what are the last two numbers? So what I was thinking of was to have a very big number in place at index n minus 1. So at this position, let's say we have 2 to the power, I don't know, maybe 29, right? And for the last number, so now it is very difficult to have that duplication thing. Still, to ensure that we are not having a duplicate number, we can think about the last bit or the least significant bit. So somehow, or wait, so if the XOR of first n minus 2 even and odd numbers is same, then what will we do? We cannot do anything, right? Or can we do something? I don't think so. Wait, what's the XOR of 1, 3 and 5? It is 7 only, right? And then I'm doing 7s or 7, so that will be 0. That's a problem. That is a big problem. How to do this? In case field does not contain any star, the answer is yes. Indeed, it contains zero. Yeah. Let's do F only. I think it is just some heavy implementation based problem. Okay, so let's do F only and then think about doing G. Hmm. We are given So I was thinking of declaring them as global because I will be requiring them a lot of times. Let's call this method is okay. Hmm. Okay. Initially, let's say it is true. Now one thing is sure that v of xy is currently a star, right? And was there some other condition here? It contains L shapes only. Where L shapes cannot touch an edge or core. Oh. So that is a problem then. Or if I think about it in the other way, so let's draw something. So we are talking about this much portion, right? So now if this guy is a dot and let's say this is a star, this is a star and this is also a star, then we will consider this one as well, this one as well, but we will not consider this value right there. Hmm. So can I create that 3 cross 3 or 4 cross 4 matrix if I am given these 3 coordinates? That will be, so I will be considering, so if I just want to get these dimensions, or I should not think about the dimensions. Yep, I should not think about the dimensions. Let's think about the coordinates only. Let's have a different thing. X, Y, and C. F is valid, and let's pass V, X, and Y. Then continue, else return false, return false. So is valid, we'll have our matrix x coordinate and y coordinate. If, so it will just return the value of this x greater than, or no, if x is minus 1, y is minus 1, x equals n, y equals m, or v of x, y equals star, or equals. So if it is a dot, then I should return true. But now, how many times will that get caught? All 9 dimensions. Const vector int dx, or I'm not sure if we can do it here as well. 1, 0, minus 1, 1, 0, minus 1. So if v of x, y is a dot, then just continue, otherwise come inside this loop. Let's define an x as x plus dx and y as y plus dy, and then call this method if is valid v of n x and y, return false. Basically if it is not true, then we'll return false, else return true. Yep. So now this has to be given these 3 coordinates. Yes, no. Yep. First initially. Okay. So now the main if else thing will come into the picture. Or let's write down the cases here only. First, say that star is this thing, or let's say first it is in this case, or there are just too many cases to be honest. Let's do this one. If x equals n, or if x plus 1 is less than n and y plus 1 is also less than n. Right? But here is one thing. So if there's a star down as well, so first consider the case where x plus 1 is less than n, right? If y plus 1 is less than m and is okay, v comma, so it has to be given 3 coordinates. So if v of x plus 1y is also a star, right? Then write this condition, and v of x plus 1 and y plus 1 is also a star, and if it is, so yeah, if not is okay, or this should have x comma y coordinate for sure. The other two coordinates depend on various things. V of x plus 1y is also a star, so it will have to come here. X plus 1y, and it will have to come here as well. So if it's okay, we should have this. V and C, then from here return false, right? Else we don't need to do anything. Now if y plus 1 is not less than m, so in the other case, consider if y minus 1 is greater than or equals to 0, v of x plus 1, y minus 1 is a star, plus 1 but y minus 1. There's still some issue, to be honest. Hmm. Okay, so let's just check if it is a valid L or not. If it is a valid L, then uh, hmm, this problem is very tricky. As we know, nights are very tricky. Hmm. Or I think I can think about a graph as well, and then find the length of the connected component. So if the size of that connected component is not equals to 3, yeah. So I think I don't need this thing. I'll be just finding the connected components again. So if this is the thing, so dx and 1 0 minus 1 1 0 minus 1 I plus dx g plus dy. But now the problem can be like the connected component like can be like these three stars. Okay, so I think I can handle that case as well. X. So I remove that method. X greater than equal 0 and x less than m. Y greater than 0 less than m. And v of x y is also a star. And then do v of x y or let's have a vector of int. Let's have edges and do edges dot push back x comma y and also do edges dot push back I comma j, right? So first of all, if edges dot size is more than 3, then f is false right away. In the other case, okay, so m1 m2 a comma b and edges m1a plus plus m2b plus plus. So there should be, so if m1 dot size is less than 2 or m2 dot size is less than 2, and also set f equals to false, else size is 2 only. It should be this not 2. And I think this is it. No? Basically, what is not true? 0th row, 8th column. This is not required. Yes, 3 no's. One yes, 2 no's. I am just submitting this one. I am not sure if this is the right solution or not. Like compilation error. Really? This scripting compiled correctly. Maybe I sounded some of it. You know what? I think it is due to this version thing. Like that destructuring is not supported in C++ 14. Yep, that was cool. I wasn't thinking about, like, I thought the solution was much harder than that, but that just got easy, so I'm happy. Now one problem is left, and I'm not sure how to approach, how to even approach that problem. I think that compilation is not really. So I was thinking about having AI equals I, but that won't work apparently. A of n distinct non-negative integers bitwise XOR of the elements on odd indices equals the bitwise XOR of the elements on even indices. So the problem was coming in the case when n is 9. So in this much part only, the bitwise XOR on even positions is equals to the bitwise XOR on odd positions. Now to make them equal in one more step, some same number should be there, but we cannot have the same number. So what's the constraint on n? Okay, so the value of n starts from 3. Yeah, if we have just 1, 2, 3, then that will work. For 7 also that will work, right? Yeah, and the XOR on odd and even will be 0 only. Now will that work for 15 as well? Like 2 to the power something minus 1? If like n plus 1 is a power of 2, then we can just print out numbers from 1 to n. And otherwise, otherwise we cannot. So for n equals to 3, we know that 1, 2, 3 will work. For n equals to 4, what will work? So we can have 0 as well, okay. So for that, 0, 1, 2, 3 will work. This looks interesting. Do we have to print? No. The numbers, okay, so here we have 12. I was thinking that the answer has to be a permutation of numbers from 0 to n minus 1, but 2 to the power 31 is the limit. That's fine. So if n is a proper power of 2, then also we know, for n equals to 5, for n equals to 5, we just removed 1. So if we are having something like this, 0, 2, 3, 4, 5, let's explain it here only. Then what will happen? Odd will be zeros or threes or 5, which is 6, and even 2s or 4 is 6. Okay, so we just remove 1. Okay, for 6 we have something very weird. Let's not go there. And 0 1 2 3 4 5 odd equals zeros or 2s or 4 is 6, even is 7. Instead we'll start from 1, and then 2s or this will be 0, this will again be 7. Or 0 1, let's remove 2 now. 3 4 5 and 6, then odd will be 0 3 5, which is 6, and 1 4 6, that is 3. 0 3 and 5 is 6, and even is 3. And let's remove 3 then. And then odd will become 7. Even will be 6 or 4, it will again be 3 only. So in the even case, when again is even, then there will be exactly n by 2 numbers on even and odd positions. And when n is odd, then there will be n plus 1 odd positioned numbers, and then n plus 1 by 2 and n by 2 even positioned numbers. And we want to make the XOR of those numbers equal. So when the number of numbers is same, then we'll do something else. Or basically what we are doing in the even case will work in the odd case as well, and we'll just append a 0. But like n equals to 3 will be a special case in such case. Or if we can do the other thing, that the XOR of, let's say, 3 numbers equals to the XOR of two numbers, then we can just have a 0 at that other position. So can't we do this in the group of three numbers? For first three numbers, we know that 1 XOR 3 is equals to 2, right? Now will that hold for next two numbers as well? Or let's think about it. What will happen when we are taking 4, 5, 6, for example? Nope, that won't work. So what should we do then? One thousand submissions. My rank is still 558. XOR of numbers at even positions equals XOR of numbers at odd positions. So I was thinking of having the last number, like if the last number contains a least significant bit, a sad bit, like if the last number is an odd number. Or maybe my old approach was correct, and when the XOR is getting to 0, then I should skip that number and instead choose some other number, basically the next odd number only. Like in the case of 135, the XOR was 7, and now if I choose 7, the XOR will become 0. But instead what I can do is I can take 9 there. So if I take 9, then 9 XOR 7 would be 14, I think. And the XOR of 2, 4, 6 would be 0. Okay, so after that I will not choose 6, but that will be 14 anyway. There are a few tricky cases. 1, 2, 3, 4, 5. Now this will be 8. If we take 6, then the XOR at even positions will become 0. Now I cannot take 7 here, I will have to take 9. The XOR till now is good, right? What should we have next is the question. So if it is not the n minus 1 index, then I should have 10, I think. So 14 XOR 10. That would be 4. But then 14 XOR 4, that would be 10. So I cannot have that thing. Instead I can take 16, I believe. Yep. Okay. But then I cannot take 18, for example. And here also if I do the XOR of 16 with 14, I will get 16. And that will be a problem. Okay, so first of all, there should be exactly n by 2 numbers that are having any particular bit as a set bit. Yep. And then the other n by 2 numbers will not have that bit as a set bit. Hmm. This one is quite a tricky problem, to be honest. So if I do something like even out, then let's say 0, 1, and then an odd number, and then an even number, and again an even number, then an odd number. So here the problem happened in the case of 4 XOR 3, which is 7, but 5 XOR 2 XOR 1 is not 7, it is 6. So let's stick to the older approach only when we are setting the value of first and minus 2 numbers from 1 to n minus 2, and now there can be multiple cases. So let's first think about the case where the XOR is already equal. Now I have no way to make them equal once again. Let's say I have a way. Let's just say that I have a way. Or let's think about the last 3 numbers. Right. Now if the XOR is equal, then I can add some 3 numbers and the XOR will be equal. If the XOR is not equal currently, then I think I should add some big number. Okay, so then also there can be multiple cases. If the XOR is not equal, like both the XORs can be even and they can be odd as well. If like both of them are even, then if one is even and the other one is odd, and that will also have 2 cases. Um, 22 minutes left. Hmm. N minus 3. And then do odd examples. Now I was thinking about doing something like this. So if n is odd, let's say 5, then 5 minus 3 will be 2. So they are considering one waste, assuming that there is only one waste indexing. So yeah, in this case, do this. So yeah, the first number will be XOR with the odd thing. Then if n is odd, V of odd XOR with I don't know, maybe this will work. Maybe it will work. What can we do? Or okay, so let's not do it like this. Yeah, this is correct. Or this should be correct. So it is even odd and last one doesn't really matter. And just for the sake of correctness, no, what? This is interesting. Let's summon this. Man, this was the first idea that came to my mind. Exactly the same idea. If you like, just go back into the video and see what I was saying. Then the first thing that I said was to have a very big number at the end of the array. And yeah, at the end, that just I got confused after solving that night question. Mm, could have done much better. But it is what it is. Not too much. You don't really. Mm. Okay, so let me explain the solutions as well now. Right, and let's open up the solutions as well. This one is G. So should I create a new file? How to create a new file? New text document, and that should be G.c. So we have G. We also have right. We have So yeah, let's start from problem number 8. So in problem A, we are given this string, this name, Taimur, and we are also given a bunch of strings, a bunch of names, and we have to print yes or no for each of the names. So we will print out yes if the given string is a permutation of Taimur. Only this spelling, this lowercase uppercase matters. So yeah, if that is the case, then print out yes, otherwise print out no. So how I did is just I had a map. So it is a map of character to int in which I am storing the frequencies or the number of occurrences of each character since I'm having this as map of char to int, so lowercase and uppercase both will be handled. And then I'm just comparing if that frequency map of the given string is equals to the frequency map of Timur, this one, then I'm printing out yes, else I'm printing out no. Yeah, and I think I've used a very complicated way for printing out this. I think just doing m equals to mp, and then yes, else no. If I just submit this thing, then also I think this will work, but I will not submit it currently. Maybe I will submit it when the contest ends, who knows. But here for checking, I am first comparing the size of both maps. So like if the given name, like if the names given in all the test cases contains more characters or less characters than Timur's map, then I will print out no right away. Otherwise I will compare the frequencies of characters in Timur. So if the frequency is equal, then I am not doing anything, otherwise I am setting f2 false. At the end, if f is true, then printing out yes, else no. So that's how problem is done. This was a good problem A. I'm not saying it is an easy or a hard problem, but it was a good A problem to be fair. And okay, so this problem will happen next. For problem B, yeah, so this was a easy problem, and I think it is safe to say that it is an easy problem. We are given two strings. Yeah, so these are, let's say, the two strings RG and RB, and the person named Vasya in this problem is colorblind and he cannot distinguish green from blue, and we have to determine if Vasya will consider the two rows of the grid to be colored the same. So it was an easy problem. We just had to check if for a particular index one string contains R and the other string does not contain R, basically can contain G or B. So for example, in this case it is R and this one is B. Then we know that at this point Vasya can distinguish the two strings, right? Like these two characters will not help him distinguish the two strings. Similarly, in this case, like all are R's and here all are B's. So in this case also it can distinguish between the two strings. And here apparently it cannot distinguish because G with G will not help him, B with G will also not help him, R with R will not help him, and G with B will also again not help him, B with G will not help him, right? So this way problem B is done. Let's look at the code. I am having both the strings as S and S1. So yeah, just the same conditions. If the first row contains R and the second row does not contain R at the same index, or if the first row doesn't contain an R at an index and at the same index the second row contains an R, then I will print out yes, otherwise I will print out no, right? So we had to print yes if it cannot distinguish. So in this case, that it can distinguish both rows. So I am setting f as false, and if f is false, like it can distinguish, so I am printing out no. I think you must have understood the solution by now. Let's look at problem C, word game. So three guys plays a game. First, each person writes down and distinct words of length 3. Yeah. So this problem I did it in kind of a brute force way, just a bit optimized. We have three persons and they will play a game for n turns basically, and they will give us n names, all of length 3. Then we will assign them some score on the basis of the names that they give, right? And the score will go like this. If a word was written by one person, like if only one person has written that word and the other two persons have not written that word, then the person will get 3 points. If a word was written by two people, then both of them will get 1 point. If a word was written by all of them, then nobody will get any points. So in the code, I have first taken the input and sorted all the names for a particular person. And then for each word, I am doing a binary search for basically all the three persons, like the names that all the three persons have given, and finding out if those words contains the current word. So the value of sum can be at most 3 when all the three persons have given the same name. So in that case I am not doing anything. If sum is 1, then that means only the current person has given the name, so I am adding 3 to the score of the current person. Else if the sum is 2, then I am adding 1 to the score of the current person, because there exists one more person that has given us the same name, right? So in this way I am handling the case where one person has given us the same name twice or more than 2 times, right? Because let's say the first person has given us a name 2 times and the other two persons have not given us the same name, like even for once, then the value of sum will be 1 only, because for the first person only it will give us 1. So binary search will return true or false only. For true it will be considered as 1, for false it will be 0, right? So yeah, this plus thing is only to handle the duplication thing, and then I am just printing out scores. Cool. So this was okay. So this was also an easy problem, but yeah, if you haven't solved any problem till now of sorting, then I think this can be a problem. Or okay, so I didn't read this line. So and distinct string. So one person will not give the same name twice or more than 2 times. So yeah, I think just having a map will also do the work. Just keep the frequency of all words will also do the same thing. Cool. For this problem line, and people in a horizontal line, each looking either to the left or the right, each person counts. Yeah. So in this problem we have to maximize the value of the line, and the value is nothing but the sum of each person's count, and the count of each person is the number of people that are in the direction in which the current people is looking. So for example, in this case, LRRLL, for this person he is looking to the left, he or she, doesn't really matter, it is looking to the left, so the count for this one is 0. He is looking to the right, so in the right direction we are having 3 people, so the count for this person will be 3. The count for this person will be 2 because there are 2 persons to the right. For this one the count will be 3. For this person the count will be 4. So we have to print the value k times and the maximum value of the line. Yeah, so we have to determine the maximum value of the line if we can change the direction of at most k people, where k varies from 1 to n. Cool. So if you look at the problem more carefully and find, so yeah, you just need to find out the case where you are having the best value. Like if n is 6, then what will be the best value? The best value will look like something like this. We have 5 here and 5 there, and we have 4 here, and then I think 4 cannot be here. So what I am basically trying to say is that let's say first person is looking to the right, the second person also is looking to the right, third person is also looking to the right, and then the other 3 persons are looking to the left. So that will be my best case, right? So yeah, if we replace the directions with the count of that person, then that will be 5 4 3 and 3 4 5, right? So you can see that 5 is coming 2 times, then 4 is coming 3 times, then 3 is coming 2 times. And let's say we had a case where n is odd, so let's say n is just 7. Then the optimal case would look like this, or it will look like this. So in both cases the string would look like this only: 3, then 4 5 6. This will remain same for this case as well as for this case. So you can see that 6 is coming 2 times, 5 coming 2 times, 4 coming 2 times, 3 coming only 1 time. So this is what I have counted here. So n plus 1 by 2, and then if n is odd, then I am saying that n by 2 is also contained once. Now I am having a sum variable which will have the current sum. So initially the sum will be just like this: n minus I minus 1, and here it will be just I if the person is looking towards the left direction. And yeah, so this thing is interesting. I am doing n minus I minus 1 minus minus. This just means that, okay, so let's take the given example. Let's just take this case, and I have not written the optimal string for this case. N equals to 5, and we are given this. So what I am doing is just that, let's replace it with the optimal answer. So that will be 2 3 and 4, right? And here it will be 0 3 2 3 2, or 3 and 4. So I am just saying that initially it is 0, so m0 minus minus doesn't really do anything, but m3 minus minus will say that, okay, we don't need to, let's say, change this guy, right? And then m2 minus minus will say that let's not change this one. M3 minus minus we'll say that let's not change this one, and now let's not change this one as well, and we will change only one guy, like the direction in which that guy is looking, and we'll have the most optimal answer. So in this way, first, okay, so this push operation is of no use. So first I'm finding out all the basically all the numbers that can be improved or that should be present in the final answer but that are not currently present in the answer, right? So yeah, in this vector VB I am having all the counts that should be present in the optimal answer, and yeah, here I am sorting the values because I'm sure that if this is the case, then only this 0 has to be replaced, or only the smallest possible value in the given array, given count array will be replaced. Every time only the smallest value will be replaced by the biggest number that is not currently present but that should have been present, right? Because it is just a greedy approach. I'm not doing anything like DB or something else. It is just a greedy approach. Like I'm just replacing the smallest positive number with the biggest positive number to have the sum as big as possible, or and also the effect of that change to be the maximum. So this is kind of a two-pointer thing. If we just debug this V and VV, oh wait, what? So these, I think I changed. I already removed one push operation and I was solving the problem. So like these two are also important because through these things I am keeping track of all the counts of various people. So here I am just like sorting all the counts, and the smallest count will be at 0th position and second smallest will be at first position and so on. So one by one I will replace them, and I am also having an answer vector. So it is possible that like in this case only after one operation I was having my optimal answer. Like if I just replace this 0 with a 4, and then I am having an optimal answer, and after that we don't need to do any changes and just push back the optimal answer for the remaining number of times. So if Vi is greater than Vbi, then I am just breaking it. I think, okay, so this is just for safety measures. Otherwise I am updating the sum with the difference of the greater number that is going to get added minus the smaller number which is going to get removed. Then I am like changing the pointer to point to the next number and putting that sum into my answer, and then just printing out the answer. So this problem was very implementation based, and I think it was a good problem. Not saying hard or easy. I also took some time to solve this problem. Counting rectangles. So this problem was, I don't know, an easy one or a hard one. I solved it with the help of 2D segment tree. If there exists some easier solution, then I'm sorry. But this whole code, if you just go back into the video, I didn't write myself. It is just standard 2D segment tree template, which I don't remember from where I copied, but I think Codeforces. I think I just copied it from some PDF, and I'm trying to figure out the blog in which I found that PDF. So, what all notes we can take with ourselves and ICBC? I think something like this. Yeah, I think this. And then somebody shared, or maybe it was not like this. Like how your notes for ICBC look like. I think this one there was. Yeah. So this was the PDF. Sample notebook.pdf. Not sure if we can see it from here. Segment tree will attach. No. Okay, so you can find it here. Let me get back to the solution of this problem. So, like, how did I get to the segment tree thing is the question. So, if you like just go back into the video, then also you can find out how I thought about the segment tree. Basically, what I was thinking about is something like, let's say something like this: a data structure, a matrix type data structure, right? So just to have a better time complexity, I used a 2D segment tree. But if like the constraints were lower than these ones, queries are okay. But if like these constraints were some lesser than these ones, let's say 100, then I think this problem could have been solved without a 2D segment tree as well. So let's think about this matrix for a second, and then we were given these two rectangles basically. So at these positions I am updating. So for second row, third column, I will have 6 here. For third row, second column, I will have 6. So I'm basically going to these coordinates in the given matrix and updating the value present at that matrix plus equals the area of that of these two coordinates. So if let's say we are given 3 to once more, then I will do it 12. And for doing that 12 only, I have kept track of another matrix. So this way first I am updating that thing in the matrix and then updating the value at those coordinates with the value present in the matrix. And one by one I am printing out the result of the queries, and at the end I am resetting the given matrix back to all zeros, right? So in the queries, what we want to do is just to get the sum of let's say the query is given to be query is to find all the rectangles in the range 1, 4 or let's say 1, 1 to 4, 4. Basically we want to find the area of this one, right? So this is, you can just like look at it and you will get the feeling that something like a matrix will do the trick. we are just finding out the area of a submatrix inside a matrix, and using 2D segment tree we can definitely get this in like logarithmic term complexity. So that from there on I got the intuition or got the idea of using 2D segment tree. If like, yeah, I have said it earlier as well, if the constraints were on the easier part, then I would have solved it using some pre-computation and just a matrix. So in the pre-computation thing, what I would have done is to, so like at this position, at this, instead of the 0, I would have kept 80. Basically just a sum of all numbers. This, this and this. So 18 will have the sum of all numbers in this row and also of this matrix. Basically something like this. Cool. And then when we want to find the area for this thing, then I think you already know the trick for that. In case you doesn't, let me share it with you. So the area for this part, this smaller submatrix, will be the area of the whole matrix minus the area of this this smaller matrix, also minus the area of this part, and since this part has been got deleted twice, so in the end we'll add it once, the area of only this part. So that way we could have got the answer if the constraints were on the easier part, but for the given constraints I have used a 2D segment tree. Cool. For the L-shapes problem, initially I was thinking of a very complex solution, but in the end just adding these few if conditions solved the problem, and I was very happy about it. Initially I was thinking of writing if else for all the cases, but after some time I got to the idea of using a graph, let's say in this case only. Right, so I'm just adding an edge. If so, you can see that if it is a star and there is some star adjacent to it as well, then I am just considering that both stars are connected. So this way, let's say for this star, I will check for all 9 points, basically from here till like these 3 values, and also these 3 values for only this star. And this way I am checking 9 values for a given star. Or instead of that, yeah, so I think we do need that edges vector to store all the coordinates. Then if edges size is not 3, because we are ensuring that the current point is a star and it is not connected to 2 more stars, then the answer would be invalid. So I will just add f to false and print out no. Right, otherwise I will come inside this condition and I will like keep the frequency map for the x coordinates as well as for the y coordinates. So let's say in case of this L, right, so in case of this L, we know that there are exactly 2 points with the same column number, right? This one and this one have the same column numbers, and exactly 2 stars with the same row number, right? Similarly here there are two there are two stars with the same column number and two stars with the same row number here only, so you can just see all valid stars and find out that particular pattern. So if first of all there will be only two distinct row numbers or column numbers, so if the size of both maps is not equals to 2, that means that we are either having one or three distinct columns or distinct rows, so in that case that will not be a valid L. So if that is the case, it is not a valid L and I am just printing out 2, otherwise yes. Cool, so this is how I solved this problem. For problem G, I think it was just a random approach. I don't know how to explain it logically, but so what I thought is that let's say that the first n minus 3 numbers contains first n minus 3 numbers can be any numbers, but they are for sure less than let's say 1 left shift 20, right? First n minus 3 numbers are from 1 to this thing, right? And then the last 3 numbers are remaining now, and let's say there's one XOR which is right now odd, let's say it is X. The other XOR is, let's say, Y. The XOR of all even number or numbers that are present at even indices is Y, and the XOR of all numbers that are present at odd indices is equals to X. Now I have to put 3 numbers in the last 3 positions. So let's say n is odd. So in the odd case, what will happen is just that we will be doing the XOR of odd numbers, like the odd will be a result of XOR of n plus 1 by 2 numbers, and even will be a result of XOR of n by 2 numbers, right? So yeah, so if n is odd, then I will set v of n minus 3 to be a very big number, which is, let's say, 1 left shift 29. So why I'm setting this as a huge number is just because it will not like the resultant XOR. So if I do odd XOR v of n minus 3, then for sure this value will be greater than the current odd, right? Because this 29th bit will be set in this result, and if I am just talking about this odd, then it is not having that 29th bit set. It will have at most the 20th bit as set bit, or the 29th bit will not be set for sure. So if I am doing the XOR with this number, then for sure the resultant will have the 29th bit as set bit. Similarly, now even for even also I am doing even XOR equals to 1 left shift 30. So now for sure even will have 30th bit as set, right? 30th bit as equals to 1. Now the only remaining part is to make odd equals to even, so for that I can just at the end push odd XOR even, because at the end when I will do odd XOR with odd XOR even, then this odd and this odd will cancel out each other, and at the end I will be remained with even, right? So this way odd will be equals to even. Similarly, if like n is even, I think that doesn't really matter. Still, I will do just the same things, but the values of odd and even will be reversed. Like here, I'm doing odd XORed with vn minus 3. Let's just write. So if n is even, then this will not be like these two things doesn't really exist. Then both will be both will be the same values only. And then yes, this will be even. Or that doesn't really matter. So let's not talk about that. So at the end, I'm just doing one left shift 30, and here one left shift 29. And at the end, I'm just putting this assert condition. So if that becomes false at some point, then it will throw some runtime error, and at least I will be sure that there is no other, like this whole code doesn't really throw you an error, and my final result was only wrong, right? So yeah, that's how I solved this problem. And overall, this contest, I think, was, yeah, this contest went decent for me. I have ranked as 446, and yeah, my friends struggled today. Especially, oh, he's still getting positive 34. Okay, that's good to know. Okay, so that's it for today, and I will see you in the next video. Bye.